Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey everyone, Meteorologist Aaron Tuttle back with you again. It is Sunday night, just about a little after 9:30. I'm glad you're here. Please like and share this video. Tell your friends and family about AT's weather. Go ahead and share it on your wall. Retweet it, re-rumble it, whatever the platform allows you to do. We have some severe weather to talk about. We will detail the newest data coming in, hot off the presses, on the tornado outbreak event setting up for tomorrow. So that's Monday afternoon and evening across parts of Oklahoma, Kansas, and even into Nebraska. So it'll be a pretty strong storm system, probably the strongest one of the year, and actually has more ingredients that are lined up better than any other. So we're going to discuss that and what that means for you as you plan your Monday. So thanks for chiming in and checking in from where you're watching from all over the state or the country for that matter. It's good to see you guys as always on Twitter, X, and on Rumble, and on YouTube, and of course on Facebook. Speaking of which, on Facebook, I'll put that in the comments section where you can join the Facebook broadcast channel that we don't miss a live broadcast. I always send you a DM right before I go live. That way you don't miss it. Rumble and YouTube and Twitter, you guys can all tap the bell or hit the subscribe to make sure you get notified by the algorithms. All right, with all that said and done, let's see what we have here. So, first off, it's a nice evening. Just real quick, I've got 64 degrees. We're going to have a lot of nice evenings coming up in the extended outlook for this week. So it's really great weather. It's going to be in the morning and night. Kind of sip your coffee, have a late evening meal. We just got to get past Monday. After that, things are looking much better. So let's take a look here at the live view across the country. And you can see our storm system has already worked its way in here to the west. This is the infrared satellite view, which does show you all the enhancement and cloud cover associated with that. Of course, things have been quiet across Oklahoma for today after that morning stuff moved off, so it was a pretty decent way to round out our Sunday. But again, things will be changing here in the next 24 hours. This is a look at the Storm Prediction Center. They'll issue a new update here a little bit later on this evening. But the old one from this afternoon has a moderate risk of severe weather here in the red shading across a good area of Oklahoma. Otherwise, an enhanced and slight and marginal after that. Here is the the tornado on the top right, which is kind of anchored here across the I-35 corridor and points west. And then down here in the purple is the hail, and over to the right is the wind. So pretty much all categories of what we call all severe modes of weather expected. Now, if you look at some of the AI algorithms just to see how they're doing, they keep fine-tuning and finessing their forecast as well. They've expanded now northward a little bit more into Kansas. Otherwise, they still have it centered over the body of Oklahoma, pretty much right along the I-35 corridor. For the tornado aspect, same thing kind of for the hail and also for the wind. So not a really big deviation from the Storm Prediction Center either. If you look at the analogs, they also kind of favor this corridor for tornadoes, both from Oklahoma to Kansas and even to Nebraska. This is going back to compare other events that line up very favorably, in other words, very similarly in the upper levels of the atmosphere, along with the instability and the moisture, etc. It tries to match for similar events so that you can get an ideal potential solution. All right, so let's take a look here what we got in the upper levels of the atmosphere. So our storm system on Monday is going to be anchored up here to our north. Now, normally, when these upper level lows kind of come in, sometimes they'll come in from the southwest and zip across, and those are our big storm makers. Usually when they come in across Colorado, believe it or not, a lot of times they're too far to the north and west, and then we end up being capped. This one is way up here. So what in the world is the difference? Well, this has a little different look to it. There's a little extra things happening in the atmosphere with this one. First off, it's kind of coming out what we call negative tilted. So it's a little negative tilted trough axis that swings through to kind of kick off the round of storms. And there's still instability and still lift behind it in another wave. And actually the bottom end of this wave right here still has yet to go through. So it's kind of a 1-2 punch. And this one will come in during the evening hours in the early part of our overnight. So in other words, have a lot of lift with this system that's otherwise usually not present, just in the way that it's configured. And so that keeps us in the risk. And you will even notice here Here's Oklahoma state line. This little enhancement right here, that's an indication of where that lift is allowing those thunderstorms to break along the dry line. But you notice nothing happens pretty much south of I-40 here at the 7 o'clock hour, according to this particular model, just because the lift is so much more stronger to the north, which can break the cap. We will have a cap in place, and we'll talk about that here in a little bit. But here's a look also at the upper levels of the atmosphere for the jet stream pattern, where we can look at jet streaks. And if you split the pattern, split the jet in half, and we go something like this, you actually get two. You get jet streak up here to the first one, number one, and then you get number two coming in from the west from us. And in both of these areas, for this one right here, this is what we call the sweet spot for the entrance region, and over here for the exit region. And so both of these kind of are juxtaposed across Nebraska, Kansas, and even the northwestern part of Oklahoma during tomorrow afternoon. So it is aligned properly. This is a big player, believe it or not, in driving overnight convection in some severe weather, and also helping the shear. Speaking of which, we have decent shear all levels of the atmosphere, so that's not even a question this time around. We do have a lot of lift in the dry line. It's kind of stationed here and shown in the darker red coloring at 700 millibars. And you can also see the enhancement here just east of it, which indicates the storms have bubbled up or produced here off the dry line by late afternoon, looking at the NAM model. The instability in the moisture, we're back into the low 70s for dew points. Now for tornadoes in Oklahoma, we like to see dew points into the 60s as a minimum. So we definitely have plenty of juice, so to speak. So low level moisture is thick. So that will not be a problem as far as mixing out in this particular environment. The dry line is actually stationed out here, pretty much right along the Texas Panhandle. So that'll be the focus to get some of those thunderstorms to develop by late afternoon. On that, of course, that extends up northward into Kansas for the west central Kansas. Let's see. Let me zip through. This is going to be interesting because, believe it or not, this is going to have a big factor as how tomorrow goes. I want you just to see the variability in temperatures. Temperatures need to be basically into the low 80s to break the cap if we're just to go widespread, complete instability all across the state. And what we have is a very different mix. So you do see low 80s with this particular model. If I show you another one, we kind of have halvesies. We have 70s east of I-35. We got 80s out to the west. Here's another model that has some 80s out here in the western Oklahoma, but otherwise mid and upper 70s elsewhere over the body of the state. Here's one that just got low 80s pretty much everywhere. Here's one that's got split, mostly 70s eastern 2/3, 80s out to the west. Here's one that's got a mix, a lot of low 80s in there as well. Here's another one with low 80s. Here's another with mid 70s and even low 70s. Here's one with low 80s. Here's one with 70s, mid 70s at that. Here's a blend, which basically is probably the best way to go, and this is why it's concerning, because it has these temperatures right about 79 to near 80 degrees. In other words, we are like this on the cap strength, which is probably why we're going to have a little bit unfortunate storms to go up to cause us problems. So here's a look at the WRAP model. It also has temperatures, looks like, into the mid 70s. Here's another one mid 70s, and here's one in the 80s. So if you're rooting for no storms at all, what you want is widespread low mid 70s across the state tomorrow. That's hard to say because right now, it looks like it's going to be warm enough to where it's right at least on the line. So that's what we're kind of be dealing with. If you do look at the Cape and instability, and you can look at all the different models just for that time frame for tomorrow evening. And we're looking anywhere where you see the orange and the purples, really a lot of instability. And that's anchored out here across western Oklahoma to central Oklahoma, where you see these little triangles in the wind shear. In other words, that's where the atmosphere is turning with height at about almost 90 degrees worth of turning for our shear, which allows those storms to rotate. I just have the 3-kilometer NAM here, but if we look at different models, they're all pretty much aligned. If you look at each one of these. So we got, in other words, it's not even an argument as to how much instability that we have or how much shear we have in the atmosphere. So we have that ingredient in place. Again, the only argument right now is the strength of the capping inversion. So when we do get storms, unfortunately, they will be into an environment that is very conducive for strong tornadoes. In this particular case here, this is our significant tornado parameter here at the evening hour, about 6 to 7 o'clock across central Oklahoma and points to the west. So any storm that is into this area will have that potential for producing some significant tornadoes. If you look at the 8 o'clock hour, 9 o'clock hour, look how that just expands all over central Oklahoma, pretty much right along the I-35 corridor and points to the west. And these are pretty ominous numbers. The scale only goes to 10, and we're getting pretty close to that number. If I just do just a random forecast sounding in the midst of all of that, it shows ridiculous hodograph. For shear profile. In other words, what that means is that the speed shear here at the lower levels of the atmosphere gets up close to 50 knots as we turn from the surface wind of kind of a south-southeasterly component on up to almost a westerly component, about 700 millibars or 3,000 meters. And so that's a lot of turning with a lot of speed shear. So you have speed shear and directional shear. What you can see, though, this little notch right here, this little red line, believe it or not, we still have a cap even in this model. There's still a little bit of a lid hanging on there, with our temperature registered at 74 degrees. Now, if we were at this point in the evening, this is about 9 o'clock, looks like the point that I picked, if we were up closer to 80, it would be a different story. So atmosphere does cool down, of course, after sunset. So we do have that going for us. Other than that, if any storm were able to be rooted in the boundary layer, in other words, bypass the capping inversion because that storm has already been ongoing, so it doesn't need to start in this environment, it would really have an easy time to go tornadic. Like here's a number up here, that's off the scale. I think I saw 11 up here. That's pretty high. That's around the Lawton area. So point being is a lot of volatile ingredients, and this is at nighttime, so we're going 9, 10 o'clock here over central Oklahoma. Now this area does move east. It includes Tulsa and the rest of the body of the state. It's not just here in central Oklahoma. You see all the colors through about midnight. And then after midnight, things start to wind down. You see the colors start to diminish, and then things quiet down toward daybreak. The level jet dies off, and all of our instability really levels out. So let's see a few of the model outputs, and we're going to see what each one thinks. Because remember, each one is going to handle those surface temperatures a little bit different, and therefore the cap a little bit different, therefore the number of storms a little bit different. So this is the HER model as we head into afternoon. So we'll zip on into, let's see, right about 3 o'clock. And you can see thunderstorms here in Nebraska, down into Kansas. Some of these will be tornadic. There's already like a little helicity track with this one just to indicate that. Those moving eastward along the I-35 corridor, so you head to 6 o'clock. I also look down south in Oklahoma. You see those thunderstorms right there bubbling up. That's at 4 or 5 o'clock here over Oklahoma City. And then there you have those new storms out here to the west. This is going to be interesting what happens here in Oklahoma City. It's almost like there's a prefrontal trough axis ahead of the dry line. A little surface convergence looks like that may be trying to pop that off, or theta E axis. Now, the issue with that is, are we capped or not capped? Because if we're not, then those storms can go up and get rooted in the boundary layer, and that's developing directly on top of the I-35 corridor. If that were to happen, it's a forecast temperature at this point of 81 degrees. Convective temperature is 82. So according to this, we basically become uncapped about 4 o'clock in the atmosphere right here over the metro, with plenty of shear in place for tornadic thunderstorms. Now, we don't have the best ingredients for the strongest tornadoes yet. That still has yet to come as we head into the evening with a low-level jet, but it's adequate for the data to suggest an EF2, maybe an EF3 strength of a tornado. Also, a lot of analog data indicates significant hail sizes up around grapefruits in diameter, and obviously significant supercells. So this is an interesting outcome. This is kind of a newer outcome from earlier this morning. So as we go in these types of events, every 6 to 12 hours we get new data sets that come in, and they get a little bit more finesse, they get a little better resolution, and we get a little bit better of an outcome on the output with a little bit better of a consensus on the result. Regardless, here for the afternoon, we do have those other storms out here in western Oklahoma and up into the Panhandle, of course, Kansas. So it's not even a question. You guys in Kansas and Nebraska, I mean, when a storm system's like this, it's just guaranteed. You've got a nasty line of showers and storms, almost like a squall on an appearance, but a mixed bag, because you're going to have some supercells within this and tornadoes, even out ahead of it as well. So you're going to have to deal with some tornadoes regardless. And then here on the tail end is where Oklahoma splits the difference. And a lot of the models like the cap holding. They kind of draw a line in the sand from the north side and the south side, and they keep nothing on the south and most from the north. Not all of them, but a good slew of them do. So we're going to see how that looks here in the evening data as we go through time. Now for this one, at 7 o'clock, you can see more storms rolling through northern Oklahoma and Kansas and Nebraska. What about you guys in Missouri and Iowa? Yes, this is coming in around the 11 to midnight hour. Those storms affecting you. Now they will start to weaken quite a bit as far as the tornadic potential goes for the supercells, but it's a nasty looking squall line, which means you're going to have some damaging wind out along the head of this band, and you'll still probably have a few embedded supercells within this. So you probably still have a couple of tornadoes to go with, and you can also get some QLCS ones along the leading edge. So you're still going to have a pretty good round of severe storms here by midnight across central parts of Iowa and the western parts of Missouri. And of course, that trails back here into Oklahoma. And we're going to take a zoom in view of Oklahoma here in a second. And regardless, that stuff moves out of here late tomorrow night on into the rest of the states to our east, and those also dissipate toward daybreak. So that is how the HRR model looks. Take a look at the NAM. It's got a completely different look in the Oklahoma section of it. Again, we're going to zoom in to Oklahoma in a second. But just first of all, I'll show you what's going on to the north. There's Kansas, 3 o'clock in the afternoon. Up into Nebraska. There's some storms there in Oklahoma in the southwest. A little bit different look to it. Not too different, but it's almost like it has two different squall lines here. So that just indicates that prefrontal trough axis is somehow firing off some storms here, probably in a weakly or non-capped environment. So you have to watch for any of these thunderstorms here for large wind, damaging winds, and probably some tornadoes. So those will zip on through. Same kind of configuration look to it by the midnight hour here across Missouri and into Iowa and then down into Oklahoma. This model has more of a squall line look for us too, and that is because this particular model has this capped, which is an outlier compared to the rest. So we're going to take a look at that also in more detail. Some of the ensemble forecasts that we run on the experimental side, just kind of show you how they all kind of differ a little bit. I'll show you some of these different members. So there's one solution for tomorrow, like around 4 or 5 o'clock. Here's another one. Here's another one. Here's another one. See how they kind of clustered up across Kansas and across northern Oklahoma? And all of these have helicity tracks with them. In other words, this particular model that ran last night is basically that supercell mania and then a broken line up to the north from there, a little bit more of a squall line appearance. Another model that does something similar, we'll take a look at that one as well. It has them back building a little bit more here into western Oklahoma. There's also the hint of like that prefrontal activity, pre-dry line, maybe a little surface wind field or a theta E axis on an uncapped atmosphere, but there's some of those different members as well, different looks to them. So the bottom line is it's got no problem for Nebraska and Kansas and northern Oklahoma and all of these outputs. It's just the rest of southern Oklahoma doesn't have any. If we look at the AI version of the in-car suite that runs on a 40-kilometer grid. So in other words, any severe weather report within 25 miles of a point. If we look at this, the data, I'm going to zoom this right here of the second. The max probability likes basically the eastern parts of Kansas, western Missouri, and across the northern half of Oklahoma. The bullseye pretty much right around the Oklahoma-Kansas border, here about 50% for any severe weather. Now that can mean hail, wind, or tornado. So if we break that down to do tornado only, I want to show you how the probability of a tornado, even though we are going to be in a tornado environment, is around 10% up to 18%, 15% in this area. So it doesn't sound very high, does it? And again, that's a 16 or 18% around a 25-mile radius of 1 point. So basically, it's a probability way to try to capture the likelihood of seeing a tornado if you were to live in your backyard in this area. And it's about 20%. So if you'll notice, those numbers never go to 100. It's not that type of a statistical analysis. So, but what you do look for is you look for the trend. You look for where is it saying is the bullseye of the activity. I try to put this in my blog today to kind of help you understand and put some relativeness to this, because you can have storms around where you live, but if you never see the storm, right, then you're probably seeing a tornado with a 0. So that's why it's not like there's going to be widespread storms in every single one of these data points. They're going to be hit and miss along these data points. Again, that's why those numbers are a little bit lower. If you were to look at, that was the FV3 core, by the way. If we look at the HER, let's see, we'll also do the tornado only for the max probability for that same area. And it also kind of favored anywhere from 10 to about 15% here. Northeast Oklahoma, even northwestern Arkansas a little bit, southwestern Missouri is where it favored. So a little shift to the south. I can see if the newer run has come in yet. It has not yet. So we'll check back before I end this broadcast to see. So the Texas Tech, I watched it, has been very consistent. Now, it's a very decent model when it comes to tornadic environments. It has a broken line of supercells from mid-Kansas up I-35 all the way down here to northern Oklahoma, back into about the Hinton area, Cordell, maybe right along the I-40 area, Geary, maybe Weatherford. So again, this model also wants to kind of put the brakes on around the I-40 corridor. And that doesn't mean that a storm can't be just south of that. It just means that that's kind of the northern edge of where the cap is weakest enough to allow these thunderstorms to roll through. And all of these have little red lines with them, indicate the helicity tracks. So if you go through time, matter of fact, let me back this up. So this is around 3, 4, 5, 6, 7 o'clock. So 7 o'clock, it already has it through Ponca City, already now passed into Canadian and Oklahoma County for Oklahoma City. So that means late afternoon for us, pretty much after 5 o'clock seems to be a common number from that time of arrival. And then for Tulsa, probably right around 8 o'clock is when most of these storms start to come into your area. And you can see they continue kind of back building along I-40 through about midnight, and they also move off to the east. So there's still some helicity tracks on I-40 up into northwestern Arkansas as well. Now I'm going to show you on the other models. This is kind of the important take home in this stuff, because I'm showing you a lot of stuff because I want you to understand the environment. I want you to understand what we're looking at. So I could sit here and do a 30-second broadcast and say tornadoes tomorrow, and then I could say good night, everybody. And what does that do for you? Doesn't do much for me. So I want to show you where the most likely area of these things are going to occur and why they're going to occur. This is a look at the helicity track. And you see all these kind of peppered across the northern half of Oklahoma zipping through. These helicity tracks, unfortunately, will likely be relegated to tornadoes, and significant tornadoes at that. They're brighter and longer, the tracks, so example, for to speak, here. This particular one comes from Stillwater westbound. Here's one across northern sides from like Edmond to Piedmont, etc. These longer, deeper tracks indicate more of a stronger, long-lived tornado. Now, before you panic too much, I'll let you know that the models will never know the exact placement of these tracks, but the take-home is what you want to pay attention to, which is the signal for long-lived, strong tornadoes here in central and northern Oklahoma. All right, so let's go into the cap strength. This model here shows you the HER. Starts to kind of diminish. All those bright colors, the stronger the cap. So as we head into late afternoon, remember that stuff it tries to fire off on I-35 corridor? It goes into this white area. That's where it has the cap pretty much eroding. And really across most of the state, it's just kind of barely hanging on by a hair. And then that cap will rebuild during the evening hours. But by then, it already has some storms here in central Oklahoma. And then it kind of peppers still some weakness areas in the cap for the evening. Otherwise, it does rebuild back in. And you're going to see its output here. We zoom back in Oklahoma in a second as a result. But as that storm system moves east, there's still pockets here where the atmosphere seems to think that we'll still have some surface-based thunderstorms. So again, let's look at those two models I showed you earlier at a close-up view for Oklahoma. Two different complete looks. The NAM is the one that was highly capped, and it still bubbles up storms here in northwestern Oklahoma, and then down here in southern Oklahoma where it really breaks the cap down here with the low to mid 80s spiraling off that one. And that goes through the Lawton area and points to the west. We do have what looks like to be an elevated cluster of storms that move into the west side of the metro. If you look here, there was a little bit of a helicity track with this, indicating at one point that storm was trying to get rooted in the boundary layer, but after that it became elevated. Here was another one that looks like it tried to briefly have maybe some embedded tornado activity with it, or just some very large hail and damaging winds. Again, this looks like more of an elevated signal in the data. This is trying to form more of a linear look to it. So can the cap hold? You betcha. And if it does, we're in good shape. But it is such a close call, much closer than the last couple of events. Anyway, so here's 10 o'clock. With this activity still going strong, there's 11 o'clock. It's a little slower to arrive in Tulsa, but you'll still get it mid-evening. There's southern Kansas as well and southeast Kansas. And there's that line from northeast Oklahoma, just now south of Tulsa at midnight, continues down here into southern Oklahoma, and then that moves on out of the state by daybreak. So that is option number one, which is a completely different look. It's an outlier to just about every other model. All right, so I should tell you something. And it, believe it or not, though, that 3-kilometer NAM is really good at detecting cap strength. I'm just going to tell you. So we could score all by its lonesome, and I'd be happy to. I'd be happy to bust on this one. All right, so here's a look at the HER. 5 o'clock. It's got those thunderstorms breaking out here in central Oklahoma. So between 4 and 5, and these could be tornadic because, again, according to this model, the cap has been broken, and we do have ingredients for tornadoes. We don't have the ingredients for the strongest, longest-lived ones, but doesn't matter. We do have ingredients for tornadoes here, so those could be tornadic. All right, you see I'm kind of stretched up here along the I-35 corridor at 6 o'clock, and then we have new storms out here in the west. Now, every hour after 5, the atmosphere improves for tornadoes. In other words, it gets more favorable, all right, for stronger tornadoes, longer-lived tornadoes. Here's 7 o'clock. You see these little helicity tracks right here indicating long-lived tornadoes already. Here's one for the Stillwater area. Here's one up here. And remember, the models will not have the exact placement. You're looking for the trend and the general signal. Here's 8 o'clock, a long helicity track with this one, indicating pretty good tornadic thunderstorm. Little notches for these also look tornadic. So pretty much any of these at this time at 8 o'clock should be tornadic. Now here's go 9 o'clock. There's more of those little helicity tracks moving through. And 10 o'clock, 11. See, there's more of it. And believe it or not, with that new final wave in the upper levels of the atmosphere that has to kick through overnight into the evening hours, it's actually triggering additional storms on this latest model data. I thought they would all be east of us by about 8 o'clock, east of I-35, and when they were, until this new round started to redevelop. So it's going to be interesting to see what happens if we get a secondary round. But that's another tornado-producing resemblance in the data. As we go into the midnight hour, even this tail end storm has a tornado-producing look to it as we head into the midnight hour across the southern parts of the metro. And then there is the 1 a.m. Look at that long helicity track. So we may be dealing with long-lived tornado warnings just over and over and over well after midnight. There's 2 o'clock in the morning around McAllister, still a helicity track, and then they kind of move out. There's 3, they start to die down. 4 o'clock, they're gone. So it may end up just being a very long night in general terms. I know most people probably don't even care right now, but just to let you know, we are going to have a little bit of rain, maybe some weak storms in here for Wednesday, midday here across eastern half of the state as a little weak front moves through. Other than that, our next chance of rain will be out here across western and southwestern Oklahoma for Friday night, and then again Saturday night into Sunday morning out there, and then finally on Sunday night into Monday morning. Just some little rounds of showers and storms. Right now, nothing big in the data, so don't get too worked up as far as anything severe goes. We get a break after Monday here across the state. So QPF amounts for this system on Monday, and then also that little bit on Wednesday, and that little bit Friday night, Saturday night, Sunday night out here in the Panhandle in southwest Oklahoma. These are your rainfall amounts estimated by the models, and it will not be able to tack in those 2 or 3 inches of rain you're going to get underneath a supercell thunderstorm, especially if you get one that trails and trains after another. Then those you can get some flash flooding with those, and this model isn't fine enough to be able to pick that up. It's a bit more of a coarser model grid. If we do look at temperatures over the next few days, like I said earlier, it's going to be really nice once we get past Monday. Tuesday a little warm. After that, it's into the 70s for daytime highs to round out our week into next weekend. Over at lows, also back into the 50s. This is what I'm talking about. When you get those nice cool mornings and nice cool evenings, you can enjoy that weather here in Oklahoma as a result. All right, so that is what I have here for you at looking at all the latest data. So if you're like, okay, Aaron, so thanks for all that, but what's the final word? All right, so the final word, and if you're late to the party, this is it. So we'll have another cap in place for tomorrow that will keep a lid on forming storms until mid-afternoon. All right, so the earliest that cap should start to break is probably around 3 o'clock, 3:30, somewhere in that frame. 2 areas for that. One is going to be on the dry line. 2 favorite areas, northwest Oklahoma and southwest Oklahoma. The other may be a little bit of a surprise event here across the I-35 corridor along the theta E axis, and maybe a possible little bit of a surface convergence that may be forming, that may be showing up in the model data. Now, should those storms form, 2 ways to look at them. They can be a little elevated unless the cap is broken. If the cap is broken, then those will not be elevated. They can be rooted rather quickly, and they can become tornadic rather quickly, say within an hour of developing. Now, that activity looks like to develop around 4 to 5 o'clock here across the greater Oklahoma City metro area, and then moving northward along I-35 for the early part of the evening. While that happens, we have those storms out to our west, marching in, any ones that do break the cap and come east. So right now it looks like a handful of storms out west that would come east and northeast, and then you have the central Oklahoma storms that would kind of drift north. Part of the signal is for those storms here in I-35 corridor, if they were to go up here in the metro, even though the atmosphere has it pretty uncapped in that particular model that we looked at, they all moved almost due north. All right, That tells me again that it's taken advantage of the environmental flow to do so, which has a lower probability of producing a tornado because it would have more of a northeast or east component if it did so. So in the data right now, it's kind of a little conflicting. Regardless, keep your eyes out because they could do so. Otherwise, as we go every hour after 5 o'clock, here in central Oklahoma and to the west a little bit, our parameters increase for stronger, long-lived tornadoes with long-track tornadoes, meaning that a lot of times a supercell storm will produce a tornado, it'll last for a few seconds, maybe a minute or two, and it'll lift back up, and the supercell will have to go through some big, huge restructuring event before it can produce another one. In this particular case, it's more of a quasi-status where it just kind of keeps what it's doing and not changing its configuration. In other words, it doesn't, we call gust out. The RFD doesn't completely overtake the influx or in the inflow to the mesocyclone, so it doesn't cut off the tornado. In other words, so the tornado is allowed to live longer in that environment. So that's kind of how that happens. And a lot of times, those supercell storms don't have that type of an environment to work in, so they usually don't produce tornadoes that last longer than a few minutes. So in this particular case, sometimes they can produce the same tornado for a much longer period of time, for minutes, 10 minutes, 20 minutes, 30 minutes. There's been sometimes storms that will produce a tornado for an hour. A lot of those happen not here in Oklahoma. They happen more kind of in the deep south and southeast, and a lot of times they're even at nighttime. But regardless, we do have that environment here for the very, very late afternoon and during the evening up to about midnight here across the central core of the state. So any storm that has already formed and is rooted in the boundary layer, in other words, they were able to bust the cap, so therefore they are down low to the ground and they're able to get all that instability right into the core of the storm, those have the potential to be tornadic as we head into that 5 and 6 o'clock hour coming in from the west. That means here in Oklahoma City, yes, I do expect to have some tornado thunderstorms around. Now, can I predict right now to this day or to this minute which part of the city, which part of the metro is going to get hit? No, I cannot. Models are not that good. Now, tomorrow, sure, we can do a lot better of a job for that. Plus, we can look at nowcasting, which is like, 3 hours out, 2 hours out, 1 hour's out, and we can give you tracks for those as well. So that's what becomes that more specific that you're looking for. So we've got some really good model data that we can use for that type of situation. Plus, we can track them on radar and look at their general motion and all that kind of stuff. Let me think. A couple other things. When the storms first fire off in western Oklahoma, they'll probably be high-based, so it'll be hail and wind. So it may take them a while to produce a tornado, and it may not happen for an hour and a half, maybe after initiation. We'll see. There's going to be a little window there where they're going to have to deal with that. They'll eventually overcome it, though, and they will become tornadic for those that do develop. And then, like I said, the models struggle with the cap as we head into the evening. Typically, the cap builds. With the storm system structured the way it is, it's going to bring in some slightly cooler temperatures aloft, though, around that 4,000 to 7,000 foot layer, and that should kind of keep that cap much weaker during that period of time. And that's what the HRRR alluded to when it spawned some last-minute storms here across the metro area, around 11 o'clock in the evening that became tornadic. Normally, we wouldn't have any more tornadoes by then. If the storms hadn't already have happened, then you wouldn't have any additional ones. This is a little different outcome for that, so that's something we're going to have to watch. Let's see. There are a couple of other things. Matter of fact, let me go back because there were a couple of models that were coming in while we were doing that, and I just want to see if that changes anything what I've got here for your summary versus what I've seen so far. Let's see. So this model here tries to get them going in southwest Oklahoma, and they kind of move northeast to I-40 area, and they are producing tornadoes in that particular output through 7 o'clock to 8 o'clock. And then so that's right over through the Oklahoma City metro area. All right, and that moves up to the Tulsa area by 9 o'clock and 10 o'clock. There's that trail end still going through the metro. So it does a little bit south. So those are folks that are asking, is that I-40 corridor hardline in sand? No, it is not. It's a general rule of thumb in the data. It doesn't mean that storms can't fire just south of there. This particular one has it just south of there, for example. All right, that's through central Oklahoma. And then that kind of builds, believe it or not, even more to the south once it gets pretty much east of I-35 into southeast Oklahoma for the rest of the state. All right, so that was one model. Let's take a look at another. So these are other of our convective allowing models called the CAM models. They each have a little bit different physics with them. All right, so there's, let's see, 5 o'clock. moving those storms. Kind of the same look as the other one. There's that southern wind that kind of comes up closer to I-40, stays just south of it, and moves here into the metro with about 7 o'clock to 8 o'clock. Has a nice helicity track with it as it goes through the Oklahoma City metro area. There's another one on the back end of that, kind of a repeat performance on the south side of town. Then those move east, go to Tulsa by 10 o'clock, and then those continue over eastern Oklahoma. That tail end never really does get going too much. I know it cuts off there on the banner that you see, but you can see out just like the other model, it kind of stops right around the Pauls Valley area. Doesn't really build much further south than that, and then it kind of keeps going east and fizzles out. So the severity, even on these models, by midnight, drops off considerably from where it was in the hours prior. And I think that's all that's come in that I want to see. Yeah. And then we can come over here. Let me see if this thing has done anything yet. And I don't think it has. Nope. Okay. All right. So if you're new here to Oklahoma, we don't have a setup like this that often, just so you know. Some years we don't have a setup like this at all. Other years, maybe once or twice, where you have a lot of strong wording from the Storm Prediction Center or the National Weather Service, kind of a deal, or whoever it is you follow. So that's just because the ingredients are there when they're typically not as favorable in our normal events that we have. By the way, the Weather Service, I didn't show their graphic here, but here is their outline. This is based off the Storm Prediction Center, so they have their moderate risk here in red, enhanced, and slight. Up to softball size hail for sure. Some of the analogs go up to grapefruit size, 80-mile-per-hour winds, and a medium tornado potential. Now, will the Storm Prediction Center come in tomorrow and then color this whole area, instead of it being this red color but pink for high? They could. What they'll do is they'll look at the morning sounding to see how the models estimated it correctly, to see if the cap is going to be stronger or weaker than what they thought, and they'll actually probably launch some additional balloon soundings tomorrow out of Norman, maybe northern Oklahoma, and there'll be some research crews out doing research work from the universities, and they'll launch their own soundings. Storm Prediction Center will look at all that data, and if they think that the cap will not be a problem, therefore more tornadic thunderstorms, then they'll bump the severe risk up to high. Because all that means is that you have a higher probability and likelihood, because there should be additional storms in the area that we're talking about. So versus, say, maybe just 2 or 3 supercells, for example, producing tornadoes, maybe there'll be, in their mind, 5, 6, or 7. In other words, there'll be more points in this grid affected. Therefore, they have to increase the risk for severe storms. But don't get lost in that wording, because there's been slight risks that had plenty of tornadoes. There's been slight risks in marginal. There's tornadoes in marginal. There's been tornadoes in enhanced. We're just looking at a probability standpoint, in other words, of likelihoodness, is what that breaks down to. So I want to give that to you. And then for those that don't know, we talk about this a lot. And you're like, I don't know what the heck this cap thing is. What are you talking about? All right, so this is what the cap is. All right, so we have warm air that comes off the slopes of Colorado, New Mexico, and it zips through the Texas Panhandle, Oklahoma Panhandle, and Kansas. It is a layer of warm air between 4,000 and 7,000 feet off the ground. All right, we have this warm, moist air that comes in from the Gulf of Mexico, those dew point values in the 70s, and with some daytime heating and lift as the storm system comes in, we start to get these little cumulus clouds bubbling up, and they try to bump up higher and higher. But they run into this cap. In other words, this is like a lid in the atmosphere, and it prevents this area from rising through it. It's like almost a sinking motion. Really, it's just a big block. It can't do it. It's a temperature inversion. So what happens is on the edge of the cap, where the cap is the weakest, that is where you get the thunderstorms to develop. Now, in this particular example, it had the cap holding across central Kansas, but then eastern Kansas, it had the cap breaking and allowing severe thunderstorms to develop. So that's kind of how the cap shows. So you could also think about it like a balloon in your room, all right, a helium balloon. You let it go, it's going to go up and it's going to hit the ceiling, right? Well, your ceiling is the cap. The balloon can't go through it. But if you can punch a hole in that ceiling, guess where that balloon is going to go? Right through there. Same idea here, the atmosphere. The way of punching a hole is if you heat the air underneath it so much that temperature at the surface is actually hotter than that little capping layer, and therefore that's equivalent of punching a hole through it and letting that parcel of air go through and develop a storm. And sometimes you need a little help, and the help can come in the form of dry line, a little convergence. The help can come in the form of some slightly cooler temperatures from a storm system that helps to eat away at that capping layer. There's a couple of ways to break it down, but bottom line is in the springtime, this cap will hose us quite a bit. In other words, we will have storms in the forecast, and the models did not estimate the strength of the cap very well, and typically they usually underestimate the strength. In other words, the cap typically holds and we don't get our storms. And everybody's happy because if you don't get the storms, that means you don't get the big hail, the damaging wind, and the tornadoes. But when the cap breaks, then sometimes a little bit of Armageddon, depending on where you live, because you may be in one part of the state and not even affected, and the ones that are getting that thunderstorm, they're like, oh boy, cap broke, right? It's coming right for me. So that's kind of how that goes. Real quick though, at the bottom of the screen, it's the same language, 24/7, 365. It is a safety message. It always tells you what to do with severe weather here in Oklahoma and how to prepare for it, all right? How to pay attention to it. One of the key factors is how you seek shelter from a tornado. It's always on the lowest floor. It's always away from all outside walls and windows. You want to put as many walls between you and the outside as you can. Closets work great. Bathrooms, stairwells, anything you've got. If you want to fit 4 people in a closet, fit 4 people in a closet. Make room. Throw everything else out of it. You don't need that stuff. Grab a bug out bag that has your most important items that you're going to need should you get hit by a tornado, right? Because it'll be total chaos. You have a lot of debris around. So make sure you have like your ID, maybe a little bit of water, some snacks for the kids. Anything you can't live without for about 24 hours, because you're going to have a ton of people coming in to help you, all right, right out of the gate. It's just stuff you need, like medication that you cannot replace in that short period of time is the kind of stuff you'd want. Flashlight, charger, So, and that goes if you have a storm shelter, same idea. You put all that stuff in your storm shelter. When you're going to watch severe weather coverage, like for me, for example, I'll be broadcasting live. You can use your tablet or your phone, and you can watch me on all the social media platforms, Rumble, YouTube, Facebook, and Twitter X. So you can do all that. Get my weather app. It's called AT's Weather to Go. It's free. Apple, Google Play. It predicts tornadoes before they happen. And you're like, well, how does that happen? Well, believe it or not, it was an early stage of AI. So it looks at the basket of ingredients, analyzes a storm going into that environment, and then predicts whether or not it's going to produce a tornado. And then it'll give you a twisting storm alert with a number associated with it, a BTI number. So that's a tornado index number on a scale of 1 to 10. If that tornado index number is a kind of a 2, 3, or 4, it means pay attention. You've got a storm that's rotating, coming your direction. It may or may not produce a tornado. It's either just forming or it's a little ways away. It hasn't quite matured enough yet. If you get a 4, 5, and 6, it is very, very close. You might want to go ahead and go to the shelter that you have set up. If it is a 7, 8, 9, or 10, that's pretty much a guaranteed tornado. So you want to make sure you're immediately getting into your shelter. You can also get a dangerous storm alert, and sometimes that comes with a BTI number. In that it can be a kind of a mixture of things. It can be the damaging winds and large hail and or a tornado. But the specific tornado alert would be called a twisting storm alert. Now, you'll get that before you get a National Weather Service tornado warning. So it gives you more time. It can give you about 20 minutes lead time to seek shelter before you can actually get the tornado warning. So basically all it does is it helps you get prepared more. So you got to get all the kids and the pets, round them all up. Maybe it takes some time. Maybe you got to finish some business, whatever. It's going to give you more time to do that. So download it. It's free. It's called AT's Weather to Go. It's on Apple and Google Play. It doesn't cost you a thing. So use that to help you and your family, and you can put in addresses, as many addresses as you want. In other words, you want to keep tab on the kids. Maybe they're over at the in-laws or the exes. Maybe you've got another lake house. Maybe at work, you want to keep tabs on that. It'll send you those custom alerts for those specific locations. And if you're not in the path, the direct path of a tronic storm, those specific things won't bother you. So it's been built to have a very good probability of detection. We call that a POD, and a very low FAR, which is a false alarm ratio. In other words, so to put this another way, let's say you're in Oklahoma County, all right? So let's say you live in Edmond, and all of a sudden sirens are going off, and there's a tornado warning, all right? And the tornado warning from the National Weather Service is into Oklahoma County. but it's down across southwest Oklahoma County. So maybe it's going through southern Oklahoma City, and maybe the far northern edge is like downtown, the path of that. So for example, you're not in the path of that tornado. So in other words, my app would not overwarn you because you don't need to be seeking shelter at that time because you're not in that path. Now, in those cases, if the storm changes direction or if the warning is redrawn, then of course you're going to get the warning in that. But the point is, it doesn't want to overwarn you if you don't need to. But if you do hear the sirens, yeah, pay attention. Turn on the live broadcast. Pull up your radar apps. You definitely don't want to close your eyes and pretend like nothing's happening. If you do get some type of an alert, it's time to pay attention. And like we saw in the last couple of events, sometimes the movement of those tornadoes can become quite erratic. Now, those are more likely in situations where the storm is very slowly moving. The deviant motion of the tornado can do some weird things. And we've seen that because the storm itself is moving east-northeast at 10 miles per hour. That's not a big movement. These storms are going to be moving pretty quickly. At the beginning stage, maybe as much as 50 miles per hour, and they'll probably slow maybe to 35 or 40 when they become tornadic. And then they'll change their motion. So maybe instead of moving, originally starting maybe a northeasterly direction, as they become tornadic, they'll move more of an easterly direction. There was some data that suggested if there were any storms at all in southern Oklahoma, that they would actually move more east-southeast because of becoming a hard right. So I did show you a lot of data that kind of suggested that the northern half of Oklahoma is the most favorable region for severe storms tomorrow, including those that produce tornadoes. And if you notice in that data, there was very little to support anything in southern Oklahoma. Now, just because there's very little data to support it doesn't mean you can't have something happen. It's just bulk of the activity should be across the northern half, with I-40's the somewhat line in the sand. Not a hard line in the sand, but the somewhat line in the sand. So southern Oklahoma, Lawton, Altus, Duncan, you could still have some supercells coming through your area the way things are looking. It's just right now the probability is higher to your north. So it's not zero where you're at, it's just higher to the north. And I looked at all that data so we could try to fine tune and pinpoint where most of this activity is going to go. And the sweet spot skin seems to be across the northern half of Oklahoma for this event. Now, new data may come out in the morning, and it may show the cap is much weaker. And if the cap is much weaker, then everything shifts more south as well. Or I should say includes more to the south. If the cap is stronger, well, then that eliminates the south, and that pushes what's in the central part of the state maybe more to the north. So again, Oklahoma's that wild card depending on the strength of that cap and how hot we get with surface temperatures tomorrow. Kansas and Nebraska, if your guys up there, again, you're just going to have storms, period. And you're going to have a mixed bag of everything, hail, wind, and tornadoes, the way things look for you. I do want to look at one thing, though, real quick, while we were talking about this. I didn't look at this before. Let me see if I can get a little clue on some cloud cover for tomorrow. All right, so there is going to be some broken cloud deck right here in the morning hours, this little low cloud area. According to the HER, that breaks up and moves east by lunchtime, and then we're allowed to get some mostly sunny to partly cloudy skies, and that's what then allows these thunderstorms here to build. That pops up in that little axis that we talked about here over central Oklahoma. So that would be allowed to break. Oh, by the way, I didn't mention this earlier, but if you guys are in Dallas-Fort Worth, believe it or not, some of the models do actually have some rough storms going through your area tomorrow afternoon and again on Tuesday. I'll see if this model was one of them. Let's see. This one was not one of them for Tuesday, but it is one for tomorrow. So just kind of keep up. Now, I know we're kind of focused on Oklahoma and Kansas, etc. But down here in North Texas, this particular model has little bit capped, not overly strong. So if there's some weaknesses down there, you may end up getting a tornadic thunderstorm in the Dallas-Fort Worth area. And then these storms would clip southeastern Oklahoma during the evening if they were to cross over the borders. They may do something like this unless they become a hard right mover and they just stay in northern counties of northeast Texas. So that was something else to mention that I didn't think about earlier because I just got so much to discuss and forgot about it. All right. Let me think. Anything else that I wanted to just jump on? I think that was it. So my plan tomorrow is to do a live at lunchtime, so around 11:45 or so. I'll look at the new data, and then we'll see about those storms will fire in the metro area early, and then the timing for those other storms out in western Oklahoma and how they'll move through. We'll see how the cap looks on any of the balloon launches that have occurred by then, and then we'll update the forecast accordingly. I do anticipate having to cover some tornadic thunderstorms tomorrow, unfortunately, and that may be as early as, say, 4 o'clock, 4:30, maybe. So my plan is to take off work early, use a little vacation time, head home to the office, and then start doing live broadcasts for you guys. And that'll happen all the way through midnight until they drop their tornadic potential. So it'll be a long day on tracking storms. Jody will be in the comments trying to help you guys out with anything you need, and then occasionally bringing me some water. Not too much though. I can't sips. But anyway, so that's what my plan is, and then we can all deal with what happens after that. Hopefully it won't be too bad. I know there's been a lot of consensus on this particular event. And that's probably because there's not really any significant failure modes other than just the cap, which is a huge failure mode. Failure mode means what can happen that's going to mess up the environment where you're not going to get tornadic thunderstorms, right? So the only failure mode is that borderline cap strength. Is it weak, strong? Where is it at? Breaking? Is it transient? That's the $1 million question right there. That would help to either reduce or allow an increase in the tornadic storms. It won't prevent them because they're still going to happen. It's just, will that, change the number one way or the other? That's really the only thing that's going to play into. And if it's stronger, it might keep most of the storms across the northern parts of Oklahoma. And then if it's weaker, well, allow more storms down to southern Oklahoma. So that's the trade-off. It just allows more coverage and more territory to be affected. Other thing is, if you're new here and you do watch the tornado coverage on the TV stations, just know there will be, it is a production, all right? So, in other words, it is an entertainment venue. You're watching free entertainment. Unfortunately, that entertainment preys on your anxiety and your fears, and a lot of the language and a lot of the energy is very negative for that. In other words, it's to tap into your dopamine receptors, all right, and it's to get you hooked. So by hooked, you refeed the anxiety, and you're stuck in a feedback loop you can't escape from. So what a lot of people will do is they will leave the TV on, and then they'll either picture cast me like a Chromecast or AirPlay on your TV from your iPad or your tablet or your phone, or watch on the phone, and they'll mute the others. So that way you can kind of get a little bit of what they have. And so, because I have all 3 stations up, I keep them muted, but I look for their live shots from either their helicopters or their storm chasers to kind of help assist me when I'm covering the whole state. And then we can kind of look to see if there's one producing a tornado or not that it's not detected on radar, but yet somebody sees something. So I kind of do that, and then the way I cover it is very scientifically. So it's very low key. There's no emotional component to it. In other words, it's all logic based. So there's not going to be a lot of terminology used excessively, a lot of hyperbole, a lot of stuff that just gets you worked up for nothing. A lot of times when we do see tornadoes, and this will be a little difficult for tomorrow, but as long as I can control it for a little while. Anytime we do have a tornado warning, we always look underneath the tornado that's confirmed to find out where it's at, like in the layout of the land. Like the last couple events, we've had them mostly over open farmland. The majority of them have been over cow fields, minus the cows. Like that. So when that happens, you've got somebody jumping up and down and going, oh my gosh, we have an EF4 tornado. Oh my gosh, everybody take shelter. Okay, well that's great. But if you look and it's not doing anything except kicking up grass, then you don't really need to go all crazy. So I like to keep it more sane in that aspect. Now, if it turns out where it is coming into a populated area, we're going to see that too, and that just gets the seriousness of the tone. That's fine. Then it jives with reality, right? It's factual. It's not just hoopla based off of no data. So we look at the data, and then we base the structure of how you want to present that information accordingly. So my brain is in constant overdrive of analyzing so many different sources. So the part of the brain that has emotion checks out. It can't come in when I have to process so much other stuff. So it's a completely different approach to severe weather coverage that you're not going to see on the other end, because I don't have a business model where I've got to treat you poorly to get you to keep watching. So that's not the way I roll. So if that's something you want to watch, great. If you don't, you like to get your dopamine rush, go for the other guys. That's fine. Either way, I'm still going to be doing what I do here, but that's different. You don't get that anywhere else. So just want to let you know. I think I pretty much covered everything else. No weather radio, make sure you get one of those. My weather app, AT's Weather to Go, make sure you get that. How to seek shelter from a tornado. The timing for tomorrow, again, is starting around as early as 3:30 in the afternoon out in western Oklahoma, maybe 4 or 5 o'clock here in central Oklahoma if we have the early stuff kick off. Otherwise, we wait till after 5 for those storms out west to come in. Anything after 5 will have a better ability to produce tornadoes, especially later in the evening we go. That window extends up to about midnight. In that window, which is anchored over central Oklahoma, we'll have some long track tornadoes, it looks like. Yes, I do expect at least one here in the metro. I hate to say that, but looking at the data and the way it's clustered, it's just what it is. I don't know if it's going to be the north side, south side, right through. Don't know that yet. But the data does favor it. Let's see. Strength-wise, most tornadoes, 80% of them are EF 0 and 1. Then EF 2 is the next category. Tomorrow, with the shear and the instability, we're probably going to go into that EF2, EF3 category more so than a lot of EF 0s or 1s, because usually once they get going and they're in a quasi-steady mode, they usually stay pretty big and pretty strong for a while. Can you get an EF 4 or 5? You sure could. Those are rare, just as you know, 2% of all tornadoes. So even though tomorrow may have ingredients for that, they're still rare to occur. You're still more likely to get the 2 or 3, an EF2 or EF3. And those still do plenty of damage. It's just those 4s and 5s are very difficult. A lot of times the 5s have some type of boundary interaction to produce the 5. So we'll look for surface boundaries to interact with, and that can be from anything left over from a prior storm or maybe an outflow from a storm. So we'll look for those type of interactions on radar to see if that looks like something that would happen on a micro, local level. In a very short time scale. We'll look for cell mergers. Sometimes cell mergers can cause larger tornadoes than otherwise would have occurred. So we'll kind of track that kind of stuff. That's about it. Let me throw it. Let's see, what time is it? 10:30. So let me see if any of this other new data's come in real quick. And then if you had any questions that I did not answer, and I try to answer everything, before, because I can't see your questions while I'm looking at this stuff. If you had anything that you thought of, ask it now that I did not already answer, and I'll see if I can answer it. All right, so Ernie says, we have a basement in our 80-year-old wood framed office. Would it be better going there or staying in my 20-year-old brick home in a closet? So, yeah, you always want the best engineering for your building. So, like for homes, at least built to code, right? And we're talking especially most recently built homes, the last 20, 30 years, where they have anchor bolts spaced every so many foot or two. Those, and make sure, of course, the bolts are on there. That's what holds the frame down and the frame together. And if you hold the frame down to the slab, that's what allows the structure to remain to keep its integrity, right? Structural integrity. So, and that goes all the way up to EF3 tornadoes. And EF4 and 5, unfortunately, it doesn't really matter how well built the home is. You're going to get a lot of damage on the 4, and the 5 won't even be there anymore, more than likely. But again, those are extremely rare ones. So anytime you do have an opportunity to go to a more sturdy, well-built structure, use it. Now, if you're trying to make that determination as the tornado's barreling down on you, you may have waited too late. One of those deals you kind of want to plan ahead if that's the case. because you don't want to get out there and get stuck in something. Cindy asked the hail size. How's the hail size determined? It's a complicated formula, but basically it deals with the Cape values, which are very high tomorrow, like 4,000. It has to deal with lapse rates and some other ingredients, moisture, and usually a storm. This is looking at the newest data for tornado genesis. There's a little bit of a lull in hail size as the tornado is occurring, and then when the tornado stops, then your hail sizes get larger. So there's a little bit of a trade-off. It's a yin and a yang. It's rare to have both large hail and the tornado at the same time. It can happen, but it's a lot rarer than the other. Clint, oh man. Dude, we started an hour ago, man. I don't even know what to even say to you. At your particular case, you're just going to have to know there's storms coming tomorrow. You can check my noon live tomorrow, and we'll try to narrow down the exact spot. Yeah, it's good to put your pets in crates if you can do that. Fowler wants a hodograph explanation, so maybe some other time. just know there's a big curve in it that's indicative of shear. And honestly, I like the more simpler. You don't even need that. The weather community loves hodographs, and to me, they're overrated in the fact if you're looking at it just what basic ingredients are required to produce a supercell storm. I'm old school, and we were taught the old school way. I mean, hodographs are neat, but really, you just want the wind profile, and you want to see that degree of turning, the visual degree of turning and the increase in speed. That's basically what the hodograph shows you, but I just like to look at it the other way. So it's a stair-step case look to it, and we have that for tomorrow. Ina, yeah, we've had similar events that have set up like this before. The problem is I don't want to say similar too much because there is no event that's ever the same, but you can have some similarities, and there's been a few. The analogs have shown a few. Matter of fact, do I have the analogs shown up? Let me see if this new one came in. Okay, it did. Let's go check this out. Is it going to be up? Yeah, this is old, so that's not going to do any good. That's from earlier today. Probability of severe weather reports anchored here across Oklahoma and Kansas. And the other one... So yeah, it hasn't quite come in yet. Let's see. So if you look at the top 5 analogs, top 15, that exceeded at least one tornado within 70 miles of one another, it looks like it favored a big stretch of the whole plains. From the Oklahoma all the way up to the north. Let's see. That's using today's NAM data. Interesting. All right, let's go to 5 or more reports. 5 or more reports kind of centered here, where we looked at tonight's data. And even then, the probability is only around 10 to 20%. So, the setup in these analogs, in other words, that compares past events, the probability of them occurring is actually still pretty low. Long track tornado, probability of it occurring 10 to 20 to 30% here in this little area. Ironically, the analogs are really hitting hard on Iowa, northwestern Iowa, in this data set for tonight. Let's see. Significant hail. Yep. All right, let me see here. So one of the analogs used for tomorrow is April 26th, 1991. They had June 11th, 2004, May 25th, 2008. Here's one from 1993, 2012, 2005, 2010, on and on and on. So are the top 15. And then let's see here. In those particular cases, for example, let's just take a look at the April one of what year I say, 1991. All right. So in this particular case, here's where all these severe weather reports were. Okay, this little pink area highlighted the most, where you have these little black lined areas. Those are little tracks for tornadoes. And it's really hard to make this out. Like, I can barely even make it out, it's so small. But anyway, so then you have another little cluster here, northeast Texas, little spot in Arkansas. But the majority were right here across Kansas, southeastern Nebraska, and into the northern half of Oklahoma. So that is the closest analog. That's the closest system that mirrors tomorrow and the output as a result. Interesting enough, it had those storms across northern Texas, just north of Dallas, that kind of stayed on the south end of the Red River, which was a hint of that in tonight's data from the HER. And then some other storms east from there, from overnight stuff probably as well. But most of the reports were here in this little sweet spot, which kind of jives with what the data has been showing for today. And if you look at other data points, you can see in this one here for this particular year, all the storms are way up here. And so we had a similar look to the system, not exact, and therefore you had a different outcome. You had more storms up here. Here's a third one, which had storms here in south central Kansas and northern Oklahoma, with a little few extra down south and west. Here's another similar year where we had a big batch of storms out here in southwestern parts of the state, and then a little bit more up north. So that's what I'm saying. Remember, these are the closest 15 analogs that represent Monday's event. The position of the upper low, the jet stream, surface parameters, and even so, I want you to see the take home in this. Look at the variability all over the map. I mean, none of these two are identical or the same. They all vary in different aspects. So when I tell you that no two storms are alike, this right here proves it to you. It's like the snowflake thing, right? But the point is, even though you're going to have a storm system and the storm chasers or whoever else say, this looks just to me just like 19 blah, blah, blah. Well, if I look at some of these other analogs and I pick, it looks like to me like it was back in 2010, but look at the results, way different. So I don't pay a whole lot of attention to this stuff. I mean, it's good because it's a data set, just to kind of keep in the back of your head. And you do know that severe weather happened that day. But as far as location of it was all over the place. Okay, so that tells me there's going to be severe weather and it's going to be all over the place. What I care about more is what does the data tonight say for tomorrow, right? And then the location of it. That's what I want to know. When you look at the probability of the CWAS value being greater than 65, which is what you need for EF2 or stronger tornadoes, it favors this area here in southeastern Nebraska and up into this part of Kansas it only goes through about 7 o'clock tomorrow. In other words, so it does not include the few hours after that. And the new data is still coming in, so it doesn't have anything more than that. But this particular spot so far favors there to the north for the first part of the event. And then we'll see what happens in the next couple of hours in this spot when the data does come in. It may not come in here before I hang up the phone, so to speak, but regardless, we're looking at that. And then let me see if this came in. It did. So let's see what NATOcast did for tomorrow. I'm assuming a big bullseye over central Oklahoma. Yep. All right, so for him, how he breaks this thing down, it's a chance of a tornado within 25 miles of a point, and he's got us in the purple, so he's got a 45% ring right over, centered over Oklahoma City, and points north and south down like Lawton, out west toward like Hinton, up to like Ponca City, Enid. So this one really hasn't changed much, but it's much larger. I mean, look, it goes all the way down into North Texas, right? So it's a very strong signal for an overkill as far as coverage is concerned. Now, I can look at a few of his other outputs, I think, that kind of tamper that down in a way to try to be a little more accurate. This one puts that little sweet spot just west of the metro. All right. Otherwise, still under a very strong avocado area. Don't ever want to be in the avocado. All right, let's go over here to the other one. So this one tampers it down even further. He uses different little model parameters for this, and so this one's down to 15%, but still, it still has this the whole center of the state lined up. So according to his stuff, his AI stuff, the cap doesn't seem to be an issue with what the models are using. And there's that little sweet spot showing up even in this data here, just west of Oklahoma City on I-40. All right, so that's just some interesting stuff. There's a lot of things we can look at. I think I've looked at all those. I don't think this will be in yet. Let's see, current forecast. Nope, not yet. And then this will still be old. Yeah, they won't put out the new one yet until I think midnight. Anything else I want to see? Oh, I can see if these came in. No. 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 And what about this one? Oh, come on. You had to have come in by now. Nope. All right. These experimental things, they run late and they take a long time. They probably still don't have the resources to run them on a faster machine. Okay, and that one's still the old one. All right, so I don't think I have anything new, unless this guy came in. Yeah, he did, but he's not very consistent on his output as far as results go this spring. He's having some trouble. Okay, he's only up through 2 o'clock in the afternoon. And convective temperature of 82 with a temperature of 81. So he's probably going to pop up some storms here like the HER did on a weak cap. That's 3 o'clock, starting to see some stuff up here in Kansas. Anybody else? Let's see what this guy did. So the wrap model is at 6 o'clock. Has a storms kind of trying to go here on the dry line, northwest Oklahoma through Woodward down to I-40, just south of I-40 out here in western Oklahoma through 6 o'clock. And let's see, temperature, gust, convective temp of 82 with a temp of 81 in the sounding. So it pretty much says that the cap breaks with some big hail. Ship model is 3.2, wind damage is 2.0, so you're going to get a lot of wind and hail initially out of this guy. The cloud base is just a little high. That's expected. I think anytime after 5 o'clock things get a little better hour by hour, but up to 5 o'clock it's just a little high based out there as far as tornado development. So this model kind of still jives with that thinking, so nothing's changed there. Let's go back to this dude. So there's our storms at 4 o'clock popping up here in northwest Oklahoma and into Kansas and Nebraska. And these all have little helicity tracks with them for potential tornadoes. And it too has plenty of instability and shear here across Oklahoma and Kansas. Weaker instabilities up here into Nebraska, except along a thin line just out ahead of the dry line, looks like. See what the atmosphere looks like up there in southern Nebraska. So a really strong turning at the lower levels. A little weaker shear though, 20 knots. So these particular storms up here are going to be a little multicellular hybrid stuff. So your better supercell type producing tornadoes would be just across the border into Kansas. So just a reminder, because you're going to see a lot of times these little outputs. Let me go back to this one, like this for example, and I'll pop this up. Right, it's going to show a storm like right here, right? Or later on it'll have a storm like right here. And just know that even though the models are good, they're not that good. 24 hours out to tell you where the supercell will track exactly. All it will say when you do see that is going to be in the area, like in this general area, is what it does. Because it could be over here, for example, when it was supposed to be over here, right? That's a pretty significant difference. So you just have to look at it in general terms as in the area. And so we've had a lot of supercells in the area right here, Oklahoma City, both on the north side of town, the south side of town, right through town. So it's in the area. The exact track we'll know tomorrow, but for tonight, it's in the area. It's all you need to know. So in that particular case, I had made a post about it earlier today. One thing you can do is you can go around your home with your video camera from your phone and document everything in your rooms. That way you know, insurance purposes, what you have, what they were, so that you can get a comparable replacement. And when you have to fight for the insurance, you can say, aha, I got my video on the cloud. This is what I had in my house. Therefore, you must replace it. So you can do that. And then it also is good to help you for timing wise is say you've got the storm coming in your area and you're about to seek shelter and that comes over, take a screenshot on your phone. So in other words, if you're watching me, for example, in live coverage, because I'll have radar up, right? And if I've zoomed in your area, take the screenshot. Okay, so now you know the time and you know the date, and so when the storm hit. So when the insurance says, hey, when did that storm hit? There you go. Conversely, you can open up my weather app, AT's Weather to Go, or any other radar app you have, and you can put that storm, over your neighborhood area. Take the screenshot, just say, yep, look, it was right here at my house at this time on this date. So all that's good for you when it comes time to filing the claim. And then say, for example, you're hit by 2 storms, right? Say the first storm was just hail. Well, get the picture of that one. That way you've got a hailstorm. Maybe the next storm comes in, it's wind. All right, you got hit by 2 different storms. Maybe that one's got 80-mile-per-hour winds. Because that way you don't want the insurance company to say, well, you know what, this storm here only had hail. You didn't get wind for this one. You can go, but I did. I got a second storm, and here it is. So it's just good for you. It just helps you out. There are many cases I've done for consulting where I have to go back in time and I have to dig up all this archive data to prove that a hailstorm hit a particular building and then go through with the hail damage and then estimate the hail size and the wind speed and was that enough to damage the roof that particular storm. So then I have to put everything together, and then that gives that to the insurance company, and the insurance company usually goes, oh, you hired a professional? Fine, here's your check. Other than that, they'll fight you sometimes because they don't want to pay out. Now, in the cases where you have a lot of damage claims, hurricanes and stuff, I know there's been horror stories about them paying out, and sometimes they pay out, sometimes they don't, and it can be hit and miss depending on which company it is. You never know. So it just helps you document everything. That way you've taken care of what you can do, and make sure you've got good coverage. If you haven't checked it in a while, you might want to check it here recently and say, hey, how am I covered for? What's my deductible? And if you're short on anything or you think you're not covered, maybe you want to switch insurance companies. I don't know, whatever it is, you can reach out to 405 Insurance Advisors. I made a post about that for the day or other hour this evening. You can ask for Jason or Leah, and they will steer you in the right path to make sure you're good to go. I use them for my insurance when I had my carrier jack my rates up 42%, I think it was, in 1 year. I said, I hadn't even filed a claim. I said, what? I kicked them to the curb. And so those guys found me a cheaper and a better plan. In other words, more coverage, less deductible. I couldn't believe it. Way better. All right, let's see. This model is taking its sweet time coming in. This is 5 o'clock, and it doesn't have much. I had that stuff in northwest Oklahoma and then into Kansas. So it's having a tough time getting things fired up here in the rest of the state. Let me see. Convective temperature of 85 with a temperature of 84. So according to this model, it's like hanging on by a thread as far as having a cap holding. I mean, like literally, you couldn't 1 degree. I mean, come on. And the models aren't even that good resolution-wise to tell you whether or not it's on either side of that 1 degree. But if it triggers, it triggers, and it produces the storms. It does have some big hail though in the analogs, 5.5 inches in a case here for Oklahoma City back in 1997. With the ingredients that we have there, that's some big hail. That's grapefruit size hail. So if we get some storms, again, those would be some big ones, regardless of just the tornado potential. All right, I think I'm going to wrap this up because this thing is like molasses coming in, and I get ready for bed. I got a long day tomorrow. So I appreciate you guys tuning in tonight on all the socials. Again, like and share the comments, like and share the videos, and tell your friends and family about AT's weather. I'll be live tomorrow to cover them. Make sure you get my weather app, AT's Weather to Go. You can look at that. I fixed the live page on it, so you should be able to tap the live button in there, and it should take you to the page and work properly. Matter of fact, I did make a change earlier today. I'm going to go over there and look right now to see. Oh, it did work. Excellent. Okay, good. There'll be a red bar at the top of the page that says AT's Weather is broadcasting live. You see that right there? So my website, that's where that is right there. So when that does happen, it'll take you to the live page. And then in here, you have options. So you can click on directly YouTube, Facebook Live, Rumble, or Twitter, X. And each of these will be live. I used to have them embedded in the site, but all these companies have changed all their APIs and how they do calls and AJAX and stuff. And it's turned into a mess. So I just directly link. You can pick whichever one you want to watch from. And then there you go. All right, that is it for me. You guys be good. Thanks again for your support. There's stars tonight, your gifts, all that kind of stuff. And get some rest. It'll be a busy day tomorrow afternoon and evening. And I'll be here with you. All right, guys, take care. Talk soon.